Thank you. So let me start with a quick intro on who I am. My name is Rivo. I've been doing Python for about 8 years, and majority of that working with Django. Currently I'm CTO of Thorgate, which is an Estonian company doing different, mostly web-related development projects. And we're also started acting kind of like a venture capital company for startups. But today I'm talking about our experience developing web projects combining Django and React. Few words about why we're doing all of this. Today Django is still a very good framework for web applications. It provides lots of functionality out of the box, and it has a big and healthy community and ecosystem of third-party applications that extend the already very mature and stable core. But on the other hand, JavaScript has become the de facto language for front-end part and building rich user interfaces, and should not be ignored. For me, one of the strengths of Python is that it allows you to very easily glue together various technologies and use strengths of each language, each library, instead of trying to use one hammer for every solution, every problem. So let's try and combine the two. A few decisions at first. I already mentioned that we use Django for the backend. We're also using modern JavaScript and React for creating front-end. When I say modern JavaScript, I mean something like ES 2015, which is the newer, more recent JavaScript standard that makes the language much more comfortable to work with. And we want to use APIs for accessing the data from the front-end, pulling in data from the Python side, and then displaying it with JavaScript and React. And I'm also going to talk about how we use Docker to make our deploys and development environment setups easier. So what is React? It's basically a JavaScript library for building user interfaces. And it was created by Facebook around 2 years ago. Open source 2 years ago. I think they had been using it internally for quite some time before that. And it's not a very big library, and it's not a full framework. This has both advantages and disadvantages, but it makes it quite easy to start with. So you can get something up and running within 10 minutes. And some of the main benefits of React are being declarative and component-oriented, which usually makes your user interface code more modular and easier to work with. And I'll demonstrate that in a moment. Another question is, should you create the single-page application, which is all the rage these days? We have found that single-page applications have quite steep learning curve because in addition to React, there are so many other pieces that you need to learn. And I would rather recommend starting incrementally with React at first, using it only for a few components in your page. And then if you want to, you can move towards full SPA later, once you have already become more familiar with React. And that way you can leverage your existing Python and Django experience and add React only where it's really necessary and makes sense. Few words about tooling. We use Django REST framework for creating the APIs, which is the de facto library for Django. I'll talk about that later. We'll also be using Webpack for bundling the JavaScript and CSS. And as mentioned, we'll use Docker to create environments a bit easier. So let's get started. And we'll begin by looking at code of very simple Django view and its template. and then trying to convert it to use React. As you can see, we have a very simple Django template view that just renders some static HTML. And we'll start by making some changes to the content block of the template. React needs to be given a container element into which it will then render its own content. So we'll add our container div. And you can also have some placeholder content within that element. React will override it once it has initialized, but you can use it for loading indicators and such. And finally, we also need to call some init JavaScript function that will initialize React and tell it to render content into our container. So let's look at that init function. It's really simple. We just grab the container element that we defined, and then we use React DOM.render to render hello message React component into it. Now, you might see that we're using something like HTML inside the JavaScript code. It's called JSX, and it's basically React's invention. It might seem a bit weird at first, but it's actually a really convenient way of combining your templates and your view code, essentially, because most likely they're quite tightly coupled anyway. So I found that it makes a lot of sense to have them in a single source file. And you can also pass properties, like in this case, the name to the React components. And we'll see later how it can be used to pass actual data, dynamic data. Moving on to how the components themselves are defined. There are two ways, basically. One way is to define a simple JavaScript function. This is good for very simple, purely presentational components that just receive some data and then show it. In this case, we're receiving the name via properties. Props is the standard React way of being passed something like HTML attributes into your component. And the function itself returns HTML, basically. In this case, div with class message, and then hello and the name from the properties within that. So if all goes well, it should print out hello PyConLT, because PyConLT is what we're passing in as name in the init function at the bottom. For more complex components, where state is required, you need to use React classes or subclass of React component. This allows you to use local state so that you can store some of the state information within the component itself. And you can also define event handlers and generally make the code more modular, since you're no longer constrained to only a single function. Word of warning though, you might end up with a bit of code being duplicated between JavaScript parts and Python parts. For example, for form validation, because you would probably want to do form validation on front end, but then you also need to do it on the backend side. But let's look at a more complicated React component. So here we first have a constructor. We define some internal state for the component, namely counter with a value of 1. Then we define increaseCount method, which increases the counter value by 1 using setState method. setState is something that React gives you and can be used to update the component's state, and then it will automatically schedule the component to be re-rendered. So all you have to do is call setState, and React takes care of calling the render method, which in turn will update the user interface. And in the render method here, we have pretty much the same as before, returning some HTML fragment. In this case, we're also making use of the hello message component that we defined earlier. And we have a button that has an event handler for clicks on it. So when the user clicks the button, increase count will be called, which will update the component state, and that in turn will then re-render the component, and the user will see the counter value increasing. Once you're comfortable with this, you can use React dev tools in the browser, which makes it more easy to see the state and properties of each component in the browser's dev tools. You can also add Redux for managing your data and using a standard way of defining actions on that data or on that state instead of keeping those actions within components themselves. And you can also look at React Router if you want to move towards SPAs. React Router basically lets you define something similar like Django's URL routing, so that you will have client-side URL routing, which is something you'll definitely need for SPAs. And I would also recommend you not to go and try to do it all at once. Just get comfortable with React at first, and then move on step by step, because otherwise things will get too overwhelming. Next question is, how do you get data from Django side to the JavaScript side? We found that it's quite convenient to pass some initial data within the Django template as JSON or JavaScript variables. We do this for user data such as email and name, and you can also serialize view-specific or application-specific data into JSON and then add it to the template the same way. This basically lets you save an API request, because instead of having to refetch this data from the server once the JavaScript side is initialized, you have the data there and ready, and you can get the data displayed to the user faster. Also, in the init function here, you can see that we pass the items property to the MyApp component now, and use the items that we added to the HTML and the Django template. But React is more useful when you have some dynamic needs, for example, a list view with dynamic filtering or searching. And in those cases, you need to have some dynamic APIs, and as mentioned, we recommend using Django REST framework for that. It integrates with Django's models and authentication layer really well. You can basically define serializers that take your model instances and then expose some fields of those via API, adding automatic validation, all the good stuff. And it has quite a lot of built-in functionality as well, including paging, validation, API call throttling, and much more. And one interesting thing that it also gives you is browsable APIs. So instead of just getting the data as JSON or in some other format if you'd like, you can also have browser-based pages for seeing and interacting with your data. And here's an example. It basically gives you interactive browsable API like some companies such as Stripe, where you can just see the API calls, make those actual API calls to the server, see the responses, and generally browse and learn about the API in an interactive way. For the JavaScript side, fetch is the standard approach of making requests to the server. In some ways, it's replacement for jQuery.ajax calls. It's standardized across all browsers now, maybe with a few exceptions. I know that Safari didn't support it. Maybe it does in the latest version. Also, we found that some experimental additions to JavaScript, like async await keywords, make it much easier to keep your code clean. Let me demonstrate. Suppose you have a load data function in your React component, and fetching some data and then displaying it is asynchronous operation, and fetch usually returns a promise that you then have to wait for. And JavaScript now has async await keywords, pretty much like Python, so that you can just wait for the result of the fetch operation to be ready, and then wait for the JSON deserialization of that data to be ready. And then you can just go ahead and call React's setState again, which will update your user interface. Moving on to environments and deploys. We use Webpack, which is pretty much standard tool for bundling JavaScript and CSS code. Because lots of browsers don't fully support the newest JavaScript versions yet, like the async await keywords that I mentioned. So you need something that takes this modern JavaScript code and then transpiles it into something that browsers can actually read and execute. And Webpack provides a pretty common way of doing that using some other tools. I don't go into too much detail here. And in a nutshell, Webpack works like this. It takes your JavaScript files, your CSS files. Maybe you're using something like Sass for styling. It can also read that. And then all of that is processed and bundled and minified into just a single JavaScript and CSS file. It doesn't really have to be single. You can also split up your application into multiple JavaScript files, for example, if that's what you need. And another interesting thing about Webpack is that you can use it to optimize your images as well. So no more huge JPEG files, for example. I pretty much covered the advantages already. The bundling, the minifying, ability to use technologies that browsers don't fully support yet. So I would just move on to Docker. I mentioned that we use Docker for both development as well as production environments. And one of the main reasons is reproducibility and consistency. It means that we don't have situations where developers have a slightly different version of Python or slightly different version of Node for JavaScript bundling. It also makes a lot easier to set up development environment, especially when there are multiple dependent services involved. For example, usually our projects have PostgreSQL as database and Redis for caching. And using Docker means that we can, the developer does not need to have either of those installed in their machine. Docker takes care of setting that up per project. And we've taken it so far that you can just run a single make setup command when you have cloned the Git repository, and that takes care of setting up pretty much anything, everything, without any further needs from the developer. I also couldn't resist putting some Docker examples here. For example, when you need to run a specific version of Python, then Docker can be quite helpful. Also outside the web development work. You just use the official Python image, specify the version, and then you have the interactive Python shell running. One trick about Docker is, though, that Docker does not persist your data by default. So if you write any files within this interactive Python shell, then once you stop this container, the files and any changes to existing files will be lost. So you need to use Docker volumes for persisting data. And in this example, we say that the current working directory should be mounted into the /app directory inside the Docker container. So everything you then write to the app directory will persist. And I've also found it really easy to use it for running SciPy notebooks in Jupyter, for example. They also provide official images, and they have most of the tools you might need installed. So really easy. The -b argument here says that the port 8888 should be exposed outside the container, because that's where the Jupyter notebook will run its web interface. In our own projects, we also use Docker Compose, because as mentioned, our applications have different parts, like the Django part, the PostgreSQL, Redis, as well as Node for bundling JavaScript. And Docker Compose lets us define all of those different containers and different technologies in a single configuration file, and then put all of that up at once. It also makes networking among those containers easier, because you don't have to do any additional setup. And just a brief example, here's sort of how our applications run. The dashed part on the left is what Docker Compose controls, basically, and what is app-specific. So we have the mentioned Django, Redis, and other containers there. And then we have Nginx and Postgres, which are global and communicate with the containers within Docker. And we also use Docker volumes for persisting some data, like log files or static and media files. So, as mentioned, Docker helps us keep our environments consistent. This also applies to servers, because we can easily have different versions of Python for different projects which are running in a single server. We can define commands like make setup that make it really easy for new developers to start working on projects. And it takes a lot of pain out of adding new dependent services to your project. So you no longer have to think whether I really want to add Redis to my project or not, because it's pretty much no additional pain or setup for developers. Some Docker pitfalls. Tooling can be problematic, because you will need to run everything inside the same Docker containers. And tools like PyCharm, they are beginning to have pretty good Docker support now, but there are still bugs and some missing functionalities. If you do run Docker in production, don't leave your ports exposed. Docker networking is something you want to take a closer look at, because otherwise you might introduce some security vulnerabilities. And in general, you will have some problems that you can't really think ahead, and you will spend some time fighting and solving those problems. So in conclusion, I would suggest that instead of being scared or staying away from JavaScript, try to embrace it. It really has become a much more convenient language with the latest revisions. And especially with React, you can start using it incrementally. You don't need to convert everything at once. You can use it in places that demand interactivity, like complicated list views, perhaps. And Django REST framework makes it quite easy to add APIs that feed data into those dynamic user interfaces. And Docker can be really helpful for setting up complicated environments in a consistent way. And that's all from me.
Thank you, Rivo. So, time for questions.
Yeah.
Well, thank you for your presentation. I have two questions. The first one is, in React, how do you do two-way binding? Because in other frameworks or libraries, you usually have like a data instance, and what you do is just change the data and the new changes automatically. So that's the first question. And the second one is regarding the Docker. You mentioned you have a stateful containers with Postgres, right? How do you manage the backups and all the other stuff related with it? And how do you manage the user ID problems regarding the mounting the modules? Because you know the user ID mapping problem is still an issue.
Yeah. So starting with the second question, for Postgres, we just mount the whole data directory as volume. And then we can, for backups, we can run pg dump command within another Postgres container that connects to the running server and then creates a backup file into another volume, for example, so that you can get it from the host machine. The user ID issues, yeah, they can be problematic. We haven't really solved them fully, especially if you have different and unknown users, like in developers' local machines. The first question about React and two-way binding. React does not do two-way binding, because two-way binding is often something that's complicated and might introduce state inconsistencies or unexpected issues in general. So React embraces this top-down data flow, where you have state at the top-level component, and then the state is passed to the child components as properties. And to get changes or events back from those child components, you just need to pass event handlers also as properties.
Thank you for the questions, and another round of applause.
Thank you.